This is the first of two videos where I'm going to talk about sequences and series. In this video, I'm talking about arithmetic sequences and series. Second video, I'm talking about the somewhat less common geometric sequences and series. So let's start at the beginning. There are two main problem types that you'll run into. The one that we have the example in the bottom of your screen, and this type, the missing term or terms. Now, missing term or terms questions work kind of this way. You've got an arithmetic sequence, and there's one or two terms missing, and they will be in the middle. Let's talk about what an arithmetic sequence is first. Arithmetic sequences have common differences. That means if you subtract like two terms next to each other, then the result of that subtraction will be the same as if you did these two terms, or these two terms, or so on and so forth, right? So I think by eyeballing this, you can probably tell it's 4, right? So it'll be 4 minus 2 is 2, 6 minus 4 is 2, right? But how do you get there when the numbers are harder, like they will be on the test? Well, here's what you do. You first find the range between the numbers that bracket your missing blank or blanks, okay? So 4, right? It goes from 2 to 6. It goes up 4. Now, here's where people make the mistake. Time and time again, I see this. They say, well, there's 1, 2, 3 things, right? So it's got to be 4 divided by 3 because, you know, they share that equally, right? Not quite. I mean, I think, obviously, 4/3 isn't the common jump, right? This isn't going to be 3 1/3. 3 1/3 plus 4/3 certainly isn't 6. So that's not the way you need to do it. If you've ever taken a cruise or been on one of those all-inclusive vacations, you may be familiar with 3 days, 4 nights or something like that, right? That's what you're doing here. You're not looking for the number of terms. You're looking for the number of increases or decreases. There are 3 terms, but there are only 2 increases or decreases. I call them jumps because I like to have cute names for things. But you divide that range, that 4, by the number of jumps, and there you go, 2. That's your answer. Well, it's not your answer, that's your common difference. To find your blanks, you just either subtract 2 from 6, 4, add 2 to 2, and you get 4. Now, usually on the ACT, they're going to give you one that has multiple blanks. I'm still going to use one with fairly simple numbers. Let's try this. 3. Okay. Same procedure. Find the range. 15 minus 3 is 12. We'll divide that by the number of jumps. Let's find those. And honestly, you can do this with your pencil on the test. Just to be careful. Remember, write more, not less for success on math tests. Clever, right? Okay, so 3 jumps, 12 divided by 3 is 4. Now, I can add 4 to 3 to get my first one, add 4 to 7 to get my second, and then you just kind of eyeball things, right? Make sure that this is the right distance away. 15 minus 11 is 4, so that's fine. This is minus, that's fine, that's fine. There you go. Both of the problem types in arithmetic sequences have to do with that jump principle. So let's take a look at our second problem type. Day 1, Nate does 5 push-ups. Day 14, Nate does some number of push-ups. You won't really need the range here, but you're always going to need those bracket values, that first and last value. So that's going to be the first job, is calculating this. Now, when you took Algebra 2, you probably had to learn a formula for this stuff. I don't find that very helpful, frankly. There are formulas for missing terms, like the problem we just did, and there are formulas for series. Series, by the way, is just the sum of a sequence. Again, I don't care about the labels. You probably learned those formulas, but I don't want you to worry about that too much because they're kind of hard to remember. This isn't, while this shows up on a lot of tests, there'd be geometric or arithmetic sequence almost all the time. It's not something that's high yield enough for you to remember a hard formula. Instead, think about why things work the way they do, how things work. First job is to find this. So obviously the common mistake again is the jumps, right? People say, well, 14, right? So that's 5 times 14. Okay, well. And then I'll add that original 5 back in. That doesn't work the way, right? It doesn't work correctly. It's not 14 jumps. It's 14 items. And in general, with very few exceptions, and be careful with the language in the question. By the way, these are usually word problems. There are going to be one less jump than there are number of things. So there are 14 things. There should be 13 jumps. And let's actually count them up. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11. That's 10 jumps. 11 to 12, 12 to 13, 13 to 14. And by the way, I'm not above you using your fingers and counting on stuff while you're taking the test. To be honest with you, when I took the GRE in like 2008, I did that. I think it's a helpful thing sometimes. Okay. Now let's go ahead and do this. So instead of 5 times 14, we got 5 times 13 plus 5. 5 times 13 is 65 plus 5. That'll give me my last day. Or the number of increase total is 5 times 13. Then I add the 5, and that gives me my last day is 70. Okay. Now I'm going to show you 2 ways to do it from this point. No matter what way you do it, this is your first job, is finding that last day. Or last whatever. Week, whatever. A lot of times these are in terms of days. So let's start thinking about this. So 5 plus 70 is 75. Okay, that's day 1 and day 14. Let's go ahead and check out another pair. Let's say day 2. And we'll say day 13. Well, day 2 is going to be 5 plus 5 is going to be 10. Day 13 is going to be 70 minus 5 is 65. Add those together, and I get 75. Do it one more time. Day 3, day 12, well, 15, 60, add those together, 75. So essentially, what am I saying? You're going to have 14 days broken into, or not broken into, collapsed into 7 pairs. Each pair has 75 push-ups. 75 times 7 is 525. Let's kind of explain how this works. So 525 is your answer. Arithmetic sequences have that common difference. And that common difference is a lot like a slope. In fact, it is a slope. For every 1 day, I go up 5. That's a slope of 5. 1 day, 5. 1 day, 5. 1 day, 5. 1 day, 5. So if I were to graph this, it would look like this. Start at 5, go kind of like this, right? So when I start pairing things off, this and this, well, that's going to meet at the midpoint. This and this is going to have the same midpoint. Same midpoint. Same midpoint. Right? Because I'm going equally close. Equally close. Boy, that's all awkward. Because I'm getting closer equally from both sides, the midpoint, the average is unchanged. Or the sum is unchanged at 75. And I can use that information to give you my answer. And that leads me to my second way of doing it, which is very similar. Find the average of your first and last term. And here's your formula. Average of first and last times the number of days, the number of things, and I'm just going to call that the number. So what would I do here? 5 plus 70 divided by 2. Average equals sum over number. Please review that if you need to. Times 14. I don't know why I put the 14 in parentheses. 75 divided by 2 is 37.5 times 14 is 525. That's another good way to do it. So spend a little time on these. It's worth your while. Check out the video on geometric sequences and series. Very little in the way of calculation, almost no calculation. Definition, conceptual problems.